Today we are here with Gema. Gema is a senior Android engineer and a Google developer expert in Android. Gema has been programming apps for Android for more than 12 years now, 7 of them in remote. She loves to make ideas into reality or an app, warm her computer with Android Studio, and catch her own bugs. Her passion is to share every little thing she has been learning during her journey as a software engineer. She recognizes that she would not have reached the place where she is now without the wonderful Android community, and that is one of the main reasons she tries to collaborate and contribute as much as she can. So I am giving it to you, Gema. At the end, I will come and ask you our audience questions. So please drop your questions in the chat box. I will be here through the session. So if you need anything, Gema, please let me know. So over to you.
Thank you. So I'm going to share first my screen. Here we go. Okay. Can you see it?
Yes, we are seeing.
Okay, wonderful.
Thank you.
So, well, first, before starting, I would also love to give my thank you to Women Who Go Mobile, not only for having me here today, but also for all the effort they are doing in the community. I have been following you for a long time, and I find it really awesome. So keep with this hard work. Well, my name is Gema. You already know me because Selen introduced me very well. I have been doing apps for almost, I think it's 13 already years. I have also done some iOS when they didn't have Swift, so it was a bit painful. And also a bit of backend, but my favorite subject and the area I love the most is Android, and is where I have done the most of my job. Well, here we are. We are going to talk about presentation patterns. But first, I want to do a question. What is a presentation pattern? Is it an architecture? Are they the same? As you can see here, maybe this sounds familiar to you, is a famous architecture called the clean architecture, where you can see it has some layers that set the relationships between the elements or the components of our app. But for me, this talk is going to center most in this part, in how we are going to show and update the stuff in our UI. So for me, a presentation pattern is not an architecture. I know that you will go there and you see a lot of blogs or articles saying that the MVVM architecture. But for me, in my case, I have learned that an architecture is a set of rules that set the structure for your app, for your whole app, and not just for a part. And that's the reason I like to call them presentation patterns rather than architectures. Here we have another famous one, which is the architecture that we have in the Google guidelines. If you have seen them, they are really, really awesome. Where we are going to be focused today is in this part. So we are going to forget or not take in account how we are going to do our domain or our data layer, or how we are going to connect to our network, whatever. We are going to be centered in the UI. As if you already seen the questions in the stories of Instagram that Women Who Go Mobile put this week, I'm a huge Pokemon fan. So imagine that we are going to do a Pokédex app where you can see a list of Pokemons, and you can also search for your favorite Pokemon. So we are going to use this example to go through the 3 patterns we are going to talk about today. And all the patterns have something in common, and it's going to be a structure that includes a view, which is what we render in the screen, a model, which represents the data we are rendering in the screen, and an intermediator that will have different names depending on the pattern that we are talking about. So this is going to be, you know, like the body of our pattern, and then we are going to build upon this. Before I start with the first one, let's take our DeLoreans and go to the prehistory, because I think that it's always important to know the context of where we have come and how we have reached the solutions we give for granted today. So in the beginning, when I started working on Android, we just have activities, but we didn't have anything more. I mean, when I need to connect to the network, I will do that from activity. And when I needed to consume a notification or something, it will be handled from the activity. Or when I need to go to the to get data from the database, I will do it from my activity. And this ended converting our activities in monstrous or huge activities that were very difficult to work with. So we ended in something like that. So it seems like we should have been applying a pattern called MVC or Model View Controller. But as we didn't have guidelines as you have today, which is cool, well, we survived applying it the way that we could. So usually they told us, okay, the view is the layout, the XML, the controller is activity, and the model is well, whatever information you are storing. This really ended very bad, because it was difficult to test, difficult to scale. I call it the Spider-Man pattern, because it's like everyone depends on everyone. So it's the components are really tightly coupled, which is not good, because we want a code as scalable as possible and as testable as possible. So the next step was to create the model view presenter. It was created with the intention of separate the model from the view. So now we had a pattern when our view is going to depend and communicate with the presenter, and our model is going to be interacted only from the presenter, which is great. We are not communicating the view with the model. They don't have a dependency. Great. How can we communicate the view with the presenter? We use a contract. Okay, so the contract, for example, for my Pokemon app will be an interface saying which ones are going to be the methods that we need to implement in my view. For example, I will need a method to show the loading if I have, you know, a loading meanwhile I'm loading the list. Another to show the list, another to show an error if an error happened. There is another option that could be to have just one method to render a view state. And here I'm going to do an ad break, ad break to talk about view state, because they are pretty important and we are going to be talking about them in all the presentation patterns. Okay, so a view state is an object that is going to represent the state of the view, as its name says. So, for example, in the case of my Pokédex, I will have I could have this data class where I will define which is the content of the list, which Pokemons are we showing in the screen, if there is any error to show the error, and also if it is in loading state. Okay, so this is an option. We could have a data class that specifies and describes the state of my view. There is another option. With the magic of Kotlin, we can also use CL class. in the case of the seal class, we are going to have different states. So we are going to have a data class for the error state, a data class for the list, and another state for the loading state. So you will maybe are wondering, okay, so great, but which one should I use? I will say that I will try to use always the seal class view state, or if I can, but sometimes you cannot use the view state, the seal class. The seal class is preferred for the cases where the different states of your views can be separated and are mutually exclusive. For example, if I can have the list prompted at the same time that I can have an error, I cannot use this because I could not have both view states at the same time. In that case, I should use this one. But if I tend to use this one, the logic to handle it and to update it and everything will be easier than updating a field in the data class. Okay, so this is related view states. So let's continue with the model view presenter. So in the presenter, we will have, for example, when the view is created, it will call this method called onViewCreated, and then we will, from the presenter, call the view using that contract that we saw previously, and we tell it, okay, show loading, show Pokemon list, etc. Okay, when I obtain the Pokemon list, I put show loading a false and show the Pokemon list. Okay, note that I'm not using any asynchronous framework here. I'm not using coroutines or RSJava or whatever. Just because I want to center in the to be focused in the pattern rather than in the way that is going to be created. Okay, you can use whatever your team or you thinks appropriate. Okay, so it looks easy. So we have some pros, or we should have, yes. This pattern is easy to code. This pattern is easy to test. And the most important one, we have successfully decoupled the model and the view. All the interactions are going to be produced via the presenter. So it's great because if you want to test if everything is working, maybe doing unit test over your presenter, you could handle all the cases you're going to have. Then you can test the view, whatever you want, but it's great for testing. But not everything is fine. We always have some cons, and in this case is what I call the ping pong, which happens when you are continually sending messages from the view to the presenter to the view again. So for example, imagine that I click a button, then you, from the presenter, say you have to show a toast. When I show the toast, then an item is selecting the toast, then you have to come back to the view, etc. So when you are debugging or when you are trying to understand what this code is doing, is quite not difficult, but it is complex. You have to be taking care of both classes and see which piece of the code are doing everyone and follow the sequential execution. So it's not easy to follow. There is a decision diagram, which is this one. I think it is in the architectural guides of Google, which is what I mostly use to take a decision. If I have an event from the presenter, it will be handled by the UI state, will update the UI state. For example, imagine that you receive that your user location has changed in your presenter, so you will update the UI state saying that has changed. If I have an event originated from the UI, I will take a decision depending what the UI, sorry, the event requires. If it requires business logic, it will have to go through the presenter. Well, if it doesn't require business logic, we can handle it directly in the UI. For example, cases very painful that where you have to go through the presenter. I have to track when the user clicks in this button. You have to send the event to the presenter, so the presenter can call the component that tracks your the user interaction, for example. But it helps you to simplify some of the cases, so it's good to know. Okay, and then there is another con, which is that you have to handle the life cycle. So, for example, if you are using coroutines, you have to cancel the jobs that are pending if the view is destroyed or if the presenter is destroyed, depending on whatever you want to do. And you have to cancel it yourself. It's not already handled by the system or by the framework. So it's something that you have to take in account. And if there is anything that you have to take in account, is prone to errors. So it's something that is important. And then after the model view presenter, Google launched those wonderful architecture components. So we started having view models, and we also started having reactive components from the framework, which were live data. So we started using this model view model, which is more reactive. In this case, what we are doing is the view model is now totally decoupled from the view. The view model doesn't know which view is going to consume it. And the view gets the updates observing the view model. So the view model will have one of more UI states that the view will observe. If there is any change in them, for example, if we have a view state that loads a list, then the view will know and it will render the list. Again, the view model will handle the model. We don't have to depend on it from the view, which is great. And this pattern will allow us to be more decoupled from the view. In my case, in my Pokédex, we are going to have a view model, which this UI state, which basically is a state flow. I didn't want to be very specific, but in this case, I had to do it because I had to use any of the framework, but it doesn't mind if you use like data or Java or another framework. It will be the same. Will have a component that behaves the same as a state flow. So I will have this U state, which is a state flow that will be emitting all the changes. For example, if from the UI I go fetch Pokemon in this case, when I obtain the Pokemon list, I will update my UI state, and as the view is observing it, it will collect the missions. So it will render accordingly to the new state, which is great. So which cons do we have in this, using this pattern? Well, we will have easier lifecycle management. I didn't remark this enough, but here we are using a view model scope. So my jobs are going to be canceled if the scope is canceled. Here we are going only to collect when the life cycle state is started. So everything life cycle related is already being handled by the framework. We don't have to mess with that. We don't have to be worried about that. which is great. Also, view model is completely decoupled from the view, as I said before, which is great. The more decoupled our components are, the better to test, the better to scale them. So it's great. As I say, easy to test, and is the recommended, here is in the recommended architecture by Google Guides. Okay, so it's the pattern that they recommend, which means that you will have more examples in the teams that you are going to work. There are more possibilities that they are already using it. So that is definitely an advantage. And which cons do we have? Because we have cons. Well, there is a possibility that we will end with multiples US states, different US states. Here I mess up with the names. They will be called different, of course, because we will have an error if we don't do that. But for example, we could have one for Pokemon list, another for error message, another for loading UI, another for notifications. What Google says is we should try to just have one, because if we have multiple states, there is a big possibility that we end with an inconsistency in our view. But there are some cases where it's interesting to have them separated. For example, if we have components in our view that doesn't depend any of another. For example, imagine that I have a search field, and then I have a map with the position of my user. The position of my user is going to be updated frequently, and it doesn't depend on whatever I'm going to write in the search and whatever is going to show the search results. So this is a good example of having them separately. Another case will be that if your UI have lots of components, possibly you benefit from having them separate if you have components that updates with more frequency than others. So you don't are rendering all the components when you don't need to. Okay, so these two are the cases, but if you attempt to just use one US state to model everything, it will be better because it will be more manageable, more easy to test. You will avoid inconsistencies, so it will be better. And then we are going to model view intent, which is more and more reactive. This is the reactive itself, and of course it's my favorite pattern. So here we have like the simplest MVI implementation. MVI really is based on a state machine with finite states. So what does it mean? It means that you will have a state with certain numbers of changes or things that can change. Whatever. Let's go to the important part. So we are seeing here that we have our view. As always, we have our model. It could look that they are depending on each other. We will see that there are other components in the middle, so they are not tightly coupled, which is one of the things we are trying to avoid. We see that we have here an element called intent. This is not an Android intent. It's an intention of the user. It's an interaction event. Is whatever the user can do to the screen. And then we will have a state which will be the result of the user applying that modification. So the user is going to do something. This something is going to modify my model. And then as a result of the modification of my model, I'm going to have to show the user a different state in the view. So this is what MVI attempt to do. So if we come back to the Pokédex again, when we are going to model MVI, it's super useful to analyze what we have in the screen to determine which are going to be my intents. In this case, I'm going to have an intent, for example, to search something. I'm going to have an intent for when I scroll the list to load the next page. And I'm going to have possibly an intent when the page is loaded to indicate that it has to do the first fetch of the list. So that, yeah, we have here the 3 intents. We will have one for loading the list that doesn't need any parameters, so I will use an object. And then we will have the next page intent that will call the next page to be loaded in the list. And then we will have the search Pokemon intent. Okay, so this is what we have at the beginning, and now I am creating more components because it's free, no, because it's really useful. Okay, so we have our intents, and then before they reach the model, I like to convert them into actions. Okay, action is like the domain representation of what we are going to do, or what we want to do. It's like a command, really. So I have an intent, and this intent in the user intentions domain will mean this in my app domain. For example, if the user writes something in the search box and press search, it will mean that you have to search the Pokemon. So this will be very useful to the couple intents from the command itself, also to be able to map more than one intent to the same action. So we can have less action than intents. In this case, for example, remember that we have 3 intents. One was load page. Another one was next page, to load the next page. In this case, we are going to map both to next page action. And the only difference is that the load page, the first page is going to put 0 in this page indication, in this parameter. And then we are going to have the search Pokemon. How do we map this? Like here. So we have the intent load list that maps with the action next page, the intent next page that maps with the action next page, and the intent search Pokemon that maps with the action search Pokemon. Then we will have to process those actions. That means that we will have to do the command, the work that they indicate that we have to do. For example, in the case of next page, we will have to get the Pokemon list. Or in the case of the search Pokemon, we will have to get the Pokemon from search term. Okay, they are going to call a use case, a repository, whatever we have in the next layer. We can have this code in the processor, in a component called the processor, or also in the view model or in the presenter, whatever we use. In the case of this architecture, the component, the intermediator we put between the view and the model could be any of them. I have used MVI with presenter as well with view models. And then this is the part that we have already seen. We are going to, I came back. We are going to go to the other part. Once we have a result from the processor. So once we have a result, our model has been modified or has been used to retrieve information. In our case, we are not modifying anything. We are just retrieving. In this case, we are going to have a result. So for example, even if we are loading the next page, or if we are searching for a Pokemon, we are going to have a Pokemon list update. Okay, we are going to use the same result. So we will have, we could have as sub-results. One of them could be loading to be sent and sent. So the UI could show a loading, a component or something like that. Then we are going to have an error as success. If there is any error, we will send this result to the UI. So the UI can show an error, and in the case of success, we will send the list of Pokemon. And there it is. Now I have to convert this result in a state, which is the last part. So as we talked before, we could have two options regarding view state. We could have the seal class view state or the data class view state. This is going to be different based off we use one or another. For example, if we choose to use the seal class one, it's going to be something like this. If we receive a result of error, we are going to show an error. And if we receive a success result, we are going to show a view state with the list. In the case of using a data class, we will have to reduce the state. And in this case, we are going to take the old state with the previous state we had, and we are take the result we have just received, and we are going to combine both, to merge both, and we will have the new state. In this case, mostly in all the cases, we are going to want to override all the parameters, but there could be cases where we can use the old state to keep some of the parameters, because we don't need to modify, the color of the button or whatever. That doesn't depend if it is an error or if it is a success or whatever. So in the case of error, we show the error. In the case of success, we are going to set the list to the parameter of Pokemon list. And here we have our MVI. One important thing of the MVI is that they have to use, or is based, or its central idea is to use unidirectional data flow. Okay, which for me is like, you have a pipe and you send your events from one part of the pipe, and you should receive the state for the other part, which is great because you can control whatever happens there. You can test it easily. You can, unit or integration test any of the part of the pipe, which is great. Okay, and to do that, well, we need streams. We need whatever framework of streams that you already use. In this case, I'm using a state flow as example. So for example, in the view model, I'm going to have this view state, which is the state of the view. We are going to use a state flow. And then in the view, I'm going to consume the emissions that I'm going to have here. And in the case of the intents that I am going to emit from the view, I'm going to have in my view model a mutable share flow. I use a mutable share flow in this case because state flow is conflated. So if you receive the same view state twice, it will do a distinct until change, so it will only send you one of them. But in the case of the intents, I don't need that functionality, because it's better that I get all the clicks. If you click twice in the same button, I want to be aware that you clicked twice in the same button. So to emit the intents, it will be better to use this one. And then we have our MVI. This is the piece of code that I love because it's really concise, and you have what we have in the left written in code. So you have the intent flow that is going to map to action. Then we are going to map that action into a result, processing it, and then we are going to collect that state. Wonderful, and everything is done. Which pros does this pattern have? Well, it's easy to test and debug because, as I said, if you use unidirectional data flow, it's really easy to put you know, your subject under test. You can select any piece, any part of the pipe to be tested, which is great. And also you can debug it easily. You can put a breakpoint in whatever place of the pipe of any of the mappers of the faces that it has. And you can do it easily. Then it has a kind of functional flavor. So it tries all the objects that we are using here are immutable. So you will not see an object being edited. You will see where in the reducer we copy, in the we map to other objects. So it turns that the objects avoid to be mutable. And then we could have something really cool, which is called time travel, because as it is event based, you can store your first intent and then the sequential intents that you are having, and you can reproduce easily what was happening on your app. So it's great, and you can come back. There are already some frameworks that implements MVI that allow this, which is great. Also helps to avoid inconsistent states in the UI, because if you implement it in a way that first intent that goes then modify the state, and then you have another intent that modifies the state, you are not going to have an inconsistent. Also depends on how you implement the reducer, which is one of the most important parts, but it's not likely that you are going to have any. And cons, it also have cons, of course. There's nothing perfect. Here we have something that is called the single live event, which, sorry, this is in Spanish, but it means changes from the UI state that have certain duration. For example, a toast. So imagine that you have an emission of your view state saying that the view have to show the toast. And then for whatever reason, you have another emission of your state that doesn't change that value. So the toast is going to be sent to be shown again. Another case will be if you have a configuration change. The last view state had the Boolean saying show the toast to true. So when you recover the activity, the fragment, whatever you're using, you're going to have that again. So it's this kind of events or changes in the UI that you want to happen and then disappear. So there are some approaches. From my opinion, there is not a perfect one. There is no one that I like the most, because they all have its pros and cons. So you can use a different flow, which means that you have a different flow in your view model to send the limited duration events, and that's it. For example, people tend to use channel for this, because it will send the mission and it will not repeat it when you connect it again. Then you can have, you can use the same flow, which means that you will emit an intent to change the value that triggers the toast. It means that once you have shown the toast in your view, from the view itself, you will emit an intent saying remove the toast. And it will, the problem with this approach is that it will do all the flow of the MVI just for hiding a toast. And then you have the option to emit two consecutive view states. From this breaks in some way the unidirectional data flow, but it works. And it will be sending, once you have to change this parameter to say that you are going to show the toast, send another view state right after that, saying that you are going to hide the toast. So the UI will, the same time that have to render area state, will not attempt to launch the toast. Any of them are ideal. So, but are the approaches that I have seen out there. And now we have our Pokédex completed. So we have our certificate. I have generate this table to make a summary. I always say you can use whatever is good for your team. There is not a written rule that you have to use MVVM or you have to use MVP. All of them has their pros, cons. Also want to remark that, for example, MVA will be ideal for views that requires a lot of interaction, which where it's difficult to keep the view consistent when the user is constantly doing things. And also something like collaborative board chats, whatever that has to be very, very reactive. MVI, I think, is the ideal pattern, but MVVM also could be your option. And for easy things, I will use MVP, but it depends on the team. It's a decision that you have to take and go for it. And that's it.
Thank you so much, Emma.
Thank you.
It will amazing, really. I don't want to interrupt you. We passed a little bit of our time, like 5 minutes. So if it is okay with you, I want to ask you the questions from our audience. We have several questions. I noted them. Amazing. Yes, definitely. I have some talk. Oh. Yes, thank you, Gracia. So we have a question from Alex first. Alex asks, does this mean the presenter class should not have any Android .x imports?
I try to not to. For example, I have seen implementations where sometimes you need to to send, for example, which string the view have to show, and then it forces you to have a relationship with the framework. I will try not to. Okay, you can always wrap that. For example, you can create a resource provider, something like that. And I will attempt to do the presenter always, outside of the framework. So it will be easier to handle, to test it, to.
Thank you so much. So Caroline also has a question. Prior to MVVM, were the presenter classes just classes, interfaces, they've created on their own, aka not provided by the Android framework?
Could you repeat?
Yes, I can repeat that. Also, I can just send it through the chat for you to see.
Yeah. I have seen the question already. Yeah. Yes. You do it, but you did it by yourself, where there are teams that already use MVP. So we didn't have a solution from Android as we have with the view model. So we have to handle everything ourselves.
Thank you so much. We have also another question from Chisimo. As a clarification, does the presenter act as a contract between the view and the model, or does it need to contract to interact with the view?
Usually you will have the contract between the view and the presenter. I have seen both options. You could have just a contract for the view. So the presenter is the presenter. The view knows which is presenter, and it will communicate directly with the presenter. And then I have seen also another implementation where you have two contracts. So you have a contract for the view and a contract for the presenter. So that way you can have different implementations of the presenter. You can easily replace it if you're going to test the view itself. but typically it's just only a view. Then the presenter will communicate, or depends on whatever you have next in your next layer, like domain layer, use cases, repository, whatever you have there.
Thank you so much. Alex has another question. Within the MVVM, if the user interacts with the UI, will that still require a call to the view model that the view just needs to wait on? Perhaps I missed the answer to this within the diagram, but I wonder if it is will like still lead to the ping pong effect.
Well, in this case, from the view perspective, you will only have one or more statuses that you are going to observe. So when you call to the presenter to do something, for example, fetch a list or something, you don't have to wait. You just do that call, and then via those statuses, every change will be collected by you, or will reach as imagine you are the view will be collected by the view. So you don't have this ping pong effect, because you can easily see which call is doing the view, and then if you go to the view, you will see what happens if any of the parameters of the state changes. So you don't have to be there, which is the main problem with the other approach.
Chismo have another question, but I think you shared a diagram before he sent the question. So I'm still want to ask you this question again. If possible, maybe please go over the pros and cons for the MVVM happen to the GitHub at that point.
Okay, so for the MVVM, well, for me, the main pro is that is the one that Google is promoting. So it's going always to have more support. There are lots of tutorials, guides, videos explaining it. So for me, that is the biggest one. Regarding the cons, I only could come with the one regarding the streams, that you could have multiple of them. That also could happen to you, you know, in another way, in the MVP pattern. You are not going to have a lot of streams, but you are going to have the ping pong, which is kind of a lot of streams. And meant to end in an inconsistency in your view. But I will say that this is the main con I see in the MVVM pattern.
Thank you so much for the answer. So we have another question from Caroline. In MVI, is model equals to view model and view equals to activity/fragment?
Yes, or whatever you have as a view, this is the view. It will be, you know, a custom view, a fragment, an activity, a composable, whatever you are using in that. And
so we have a last question. I want to remind everyone, if you have another question, please drop in the chat box. So I will ask later that question. So we have a question from Al Brown. I use React Native. Do you believe this is a little easier for Android to navigate to pages than use driver or stack?
I don't know, because I haven't used React Native. So what I know is that, for example, MVI is pretty similar, or is based in some way in Redux. So it should be familiar for React Native developers, but I don't know. I cannot answer because I haven't used it yet.
Thank you so much. I want to ask my question to you. Do you prefer any specific documentation or that kind of thing when you are looking for something in Android?
Well, since Google released the guidelines, which are great, I think it was like a year ago or something like that, I always tend to go there, especially not regarding this part, the presentation layer, but also regarding the data layer, which is really well explained. I think nowadays is my go-to documentation. But if, for example, MVI is more difficult because it's not supported, but you can find anywhere in internet, as always.
Yes, thank you. We have another question from Laura Sanchez. Which is the pattern that you have used the most during your professional life?
I will say that it depends on the stage of my professional life. So I have gone through all the presentation layers, all the presentation patterns. Also, I did a lot of gut activities with a lot of logic there. But for example, nowadays I have more experience with MVP and MVI because the app that in which I work nowadays use both. But I have also used MVVM. My favorite one is easy to know, which is MVI.
Thank you so much for your answer. So I want to ask a last question. Do you have any suggestion for newbies in Android? I saw Dorota in the chat is new to the Android. So I want to ask you also that question.
Okay, so well, my first question, my first thought is don't get overwhelmed because there is a lot of information. We don't know everything. We are learning at the same time we are working with it. So Android is really huge. And you will be, finding your answers when you are trying to learn something new. Also, the community is really warm, is really welcoming. You can ask whatever in any of the social networks that is going to be anyone that is going to answer, which is great. And then also, if you want resources, Google have the code labs that are really cool and really useful and helps a lot. So these are my free advice.
Thank you so much again. So Laura asked last question. This will be our last question. Laura asked, do you recommend to have a mix between presentation patterns or maintain one in the app?
I will recommend as much as possible to have just one in your app because it will make easier the work in the team. All the members of the team just have to learn one way to do the things. But there could be some cases where you have to use another. So, for example, if I have an entire app using MVP and it's working great, and now I need to introduce a new screen where MVI is going to be a mismatch, I will do it. So if you can, just use one. If not, and it's justified, you will have to use more than one.
Thank you so much for this presentation. And also, I want to thank you, our audience, because they really listened to you and asked amazing questions today. So thank you all for coming and thank you all for listening. Yes, thank you so much again. Thanks everyone for joining. Please be tuned for our Android Study Club. I want to host you, Gema, again in there also.
I will love to.
Thanks again, everyone. So see you in the Slack channel, I hope. Take care.
Thank you.